Well, hello, and welcome to the VK6CS Christmas special. I suppose I should start with ho, 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 and just to get into the spirit of things, okay, now, I was listening to the repeater the other day, and there was a few people on there that wanted to know what capacitor I use to tune my mag loop. Actually, it might have only been a couple of people. Actually, I think it was one person asked me what sort of capacitor I use to tune my magnetic loop. And I thought, well, as there's a bit of interest in this subject, sorry, I'm sort of looking at the screen rather than into the camera, so I'm sort of a bit off there. I'd show you. Now, I can't remember if I've done a video on this capacitor before, or the easiest way to knock up a mag loop before. And I can't be bothered, to be perfectly honest, to trawl through all of those videos. So I'll I thought, well, I'll just quickly knock one of these things up as I was in a sort of Christmassy mood, and I just felt like sort of bouncing around a bit. So here we go. Oh, wearing a Star Wars t-shirt, of course. Being a nerd. Right, okay. Oops. What do we have here? Of course, now I can't see the... There we go. Right. Ah, yes, okay. Sorry about that. Continuing the Christmassy theme. I shall be enjoying that later on. Right, now, can I get this so that I've got to loosen this bloody thing off somehow, but never mind, let's just give it a bit of brute force and ignorance. Let's see if I can get round the tripod. Okay, so, not my design, but apparently the easiest way to make yourself a mag loop is with coaxial cable. Now, I've had some personal experience with a mag loop made of coaxial cable. A colleague at work is also a licensed amateur, and occasionally we do a bit of portable work with his magnetic loop out in the bush, and have achieved quite long range contacts, interstate contacts even, with an FT817 and using the mag loop. And the mag loop consists of 16 feet of RG58. You have to use your imagination here. Just imagine that 16 feet. And it's formed into the shape of a diamond. So you've got 4 feet, 4 feet, 4 feet, 4 feet, held or separated, held in position across the middle with a couple of retic connectors, one there, and some wooden dowel. So this thing can all be scrunched up, put in a travel bag, and you're in business. The way you would match it or connect to it is with a small toroid, and you wind a few turns around the small toroid and you just place it over that, and it hangs basically in the bottom of the loop like that. In the gap on the loop is where the capacitor goes. So that's just a J-car core. Now the fellow that made one of these up used the core specified by the guy that came up with the design. He gave me one of those cores, and I can't put my hand on it at the moment. It's got to be around here somewhere, but it's a little bit smaller than that. It's quite a snug fit onto the RG58. I found that didn't make any difference when I made a loop out of copper tube, and I had a bigger ferrite hanging on it. It was hanging quite loose, very much like that is, and that worked fine. That coupled to the loop perfectly well. When I find that little core that he gave me, I'll be putting a few turns on that, putting a few turns on this, making up one of these loops that's got 4 feet per side, diamond shape, and I'll just compare the two just to see if there's any difference. So you get your 16 feet of coax, wind a few turns onto your toroid. It's actually probably better if you use one. This is just a J-car core. Use one that you can actually wind onto and unwind once it's on the coax, because you're going to have to put a BNC connector on each end. and the BNC connectors are how it connects to the capacitor at the top of the loop. Okay, now this is now what my colleague did was have a small ABS box, and he's got a small airspace capacitor in it, you know, the sort of thing that has a 1/4 inch shaft, little airspace capacitor, won't handle a lot of power, won't handle an awful lot of volts. It doesn't matter too much when you're using an FT817, although the voltage across the capacitor is quite high. A small capacitor won't break down. If I was going to feed that loop with an FT857 with 100 watts, then the voltage across the capacitor is going to be pretty substantial, and you need a more substantial capacitor. So what I did, this is where the remember you got the RG58 with the BNC on each end. One end goes on there, one end goes on there, and then it's pretty crude, but this is amateur radio. This goes round the branch of a tree. Goes around the branch of a tree and then clips on itself. That's that grunt rope. I can't really demonstrate because I'm leaning around the camera, but you get the picture. So the string goes around the branch of a tree and it supports it like that, and the loop will just hang up. And we've had very good results with that loop, with the feed point at the bottom of the loop no more than 2 or 3 inches off the ground, so it doesn't need to be high up at all. So the capacitor inside this box is a Jennings vacuum cap. Now you can't hear it whining because it's not switched on at the moment. Just a very feeble attempt at humour there. Not quite as feeble as the Christmas theme, but never mind. Whoa. And with my usual level of prep, I don't have a screwdriver to lever that off. Let's have a look. I've got one here somewhere. Oh. This is amateur radio, as I say on almost every video. Simply because, there we go, I don't edit these videos, I just point and shoot, and you get them warts and all. Oh, there we go. Right, there we go. So that's the capacitor that's inside the box. It's a Jennings vacuum capacitor, and it's 250 puff, I think, is the maximum capacitance. And can't quite see the rating on that. I don't know if it's 5. It's either 5 or 10 kV. I can't remember which. But if you're making a mag loop, you're going to put an 857 into it. A variable capacitor that size, you can see how big it is relative to my hand, will be fine for that application. Now, I am aware that with mag loops you get a lot of current running through them, and there are probably less lossy ways of connecting to the capacitor than I've got here, but I just put it together like that. It tunes the loop fine. I just used it on 3 meters of copper line, which I formed into a circle, hung it up in the lounge room, and got a 5 and 8 using 50 watts from about 100 kilometers away. So I was quite happy with that. I thought that's obviously working quite well. So I don't know if you can see that, but you know, got fairly thick wire there, and it's connected to the outer of the BNC socket. So you're only interested in the coaxial braid, which plugs onto there, and you use that to tune your loop. So that's just a little bit on the mag loop, prompted by a question the other day. I hope that's answered most of the queries regarding the mag loop. But I'll just show you. So you got the capacitor at the top, got the BNC socket on either side like that. You have 16 feet of RG58 coax, which you form into a diamond shape, is the easiest. Runs through the toroid at the bottom like that, and back up to that like that, and just have a wooden dowel or something to keep it apart like that. This is in a box that you hang on a tree. On a tree branch. Have a couple of leaves on there like that. Like that. And then you have a few turns around here, connected to another BNC socket, which goes off to your radio. And that's it. And there's a couple of ways you can tune it. You pick a frequency of interest, you adjust the capacitor for maximum noise, that'll get you in the ballpark. You can press the PTT and then adjust the capacitor. Because they're a bit finicky with regard tuning magnetic loops, sometimes you have to sort of make an adjustment to the capacitor and then step away, make an adjustment to the capacitor and step away. I usually tune it with a antenna analyzer, which makes it much easier. But what would make it easier still probably is take the knob off, put a bit of fuel line or something like that on the shaft. It's got to be insulating material obviously, because you get very high voltages on here, you don't want to touch it. And bring it, you know, a metre away or so, maybe more. A reasonably stiff stuff, that's why I suggested fuel line, and then you can turn it, you can adjust the capacitor and be outside of the sort of near field of the mag loop. And was there anything else? Oh yeah, so if you're making one of these and you've got an antenna analyzer, the thing to do is to these only work on one band typically, happily anyway. So if you make it 40 metres, set the capacitor mid-range, you'll find that you can tune to the frequency that you're interested in quite easily, or you should be able to. And you may find when you put your analyzer on there that it's not 50 ohms, you may have an impedance mismatch. And that's when you need to adjust the amount of turns on your little toroid. So, you know, if it's a if the impedance is high, take a few turns off or a couple of turns off. If the impedance is low, put a couple of turns on until you get a 50 ohm match. So when it's tuned to the frequency you're interested in, on the band that you're interested in, you want to see about 50 ohms presented by the few turns that are over that. Through the little toroid. So it can be a little bit fiddly getting that right, but once you have, you can get some pretty good results with this. And as I say, it's an ideal travel antenna because you just scrunch it up, throw it in your travel bag. All right, well I hope you found that interesting or useful, or both, as always. Thanks for watching, and enjoy your Christmas.